Hi guys, these are the notes for quadratic format. So, in some cases, or like you'll probably remember, we have x squared plus 4x plus 4x. We are able to use the x factor, 4 and 4, 2 and 2. We're able to say that this is x plus 2, x plus 2. Right? So that's our old factoring. And that's because it was in this format. It was in the x squared, and then the x, and then the number. Right? It's always been in that format when that's how we know to use the x factor if possible. So sometimes we're in that format and we can rewrite a polynomial in this same format where there's the a and then the b and then the c. So for example, if we say that u is equal to x squared, right? So we're just going to say, like, for this time period, anytime we see x squared, we're going to replace it with u. Then we can turn something like this, x to the fourth power, into x squared squared, because that would be x to the fourth, and then 12 times the x squared, and then 32. So we see that same format start to come alive, but instead of the x squared squared, we're just going to put a u every time that we see x squared. That way we now have that format that we're used to, the squared, the u, and the number by itself. If the u is throwing you off, don't worry too much about the letter so much as we're replacing it, right? We could use a star or anything. So let's see what it looks like. This one says here we have x to the fourth, x squared, and a number. So let's say for right now that x squared is going to be u. So I could say that this is x squared squared, or I could say that this is u squared. This x squared is also turning into u, so 2u minus 24. I write this up here just as a reminder to myself at the end of the problem. So for this one, I'm going to factor normally negative 24 and 2, multiply to get negative 24, add to get 2. I know that those numbers are 6 and 4, and I need a negative. I want to do 6 minus 4. So I'm going to have u plus 6, u minus 4. Okay? And then remember that the u is the same as x squared. So I'm going to change those back into x squared. So I'm going to have x squared plus 6, x squared minus 4. So that is technically our factored form. However, I see that I know from yesterday, our review of difference of squares, I see that that is 2 squares. So I would say that this is x plus 2, x minus 2. So I have to go an additional step to turn this into that. 6 is not a square, so I'm just going to rewrite that like that. This is my answer. If I multiplied those three things together, I would get back to this answer here. The u substitution, I know it feels like, oh, I can just remember that there's an x squared here. I don't need to write the u. I think that's totally fair. We use u substitution a lot in calculus, so I wanted to get you used to that idea. But if you're feeling okay with x squared, go for it. So let's try another one together. So I can see I'm going to again write u equals x squared. So this is like x squared squared. I'm going to turn that into u squared. This is 24 times x squared, or 24u, and minus 25. So I have the x factor, negative 25, negative 24. I know that 25 and 1 make negative 24, so something like negative 25. So I would have u minus 25 and u plus 1. From there, I'm turning my u's back into x squareds. X squared plus 1. I'm going to check and see if anything is a difference of squares. I see that this one is x squared and 25, so I'd have x plus 5, x minus 5, and then I'm bringing this x squared plus 1 straight down. Okay, so that is my answer for that one. This multiplied together would give me that. Okay. If I'm looking at this next one, I see that I have x to the fourth would be x squared squared, so that'd be u squared. But I see this one is just x, right? So I would have plus 5x. I can't turn x into a u, and it's not an x squared. So there's not really anything I can do here. Besides, there's not anything I could do in order to factor it. So I would just say that this is unfactorable. Factorable. Sometimes we call this prime. Okay. And then number 10 looks a little different because it's x to the 6th, but I can see that this is x to the 3rd. It's a half of it. So I'm going to set my u this time equal to x to the 3rd. So now this is going to be x to the 3rd squared. So I'm going to replace that x to the 3rd with a u squared. I have minus x times, or 6 times x to the 3rd. So I'm going to replace that x to the 3rd with just a u. And I'm got my plus 5, trusty plus 5. In this case, I would have 5 on top, negative 6 on bottom, negative 5, negative 1. So in this case, u minus 5, u minus 1. So that would be, I'm going to replace those u's back with their x to the 3rds. X to the 3rd minus 5, x to the 3rd minus 1. So I'm almost done. The problem is that, like I learned yesterday with the sum and difference of cubes, I have to check it out. 5 is not a cube, so I know that this one is staying like that. However, x to the 3rd plus 1, 1 is a cube and x to the 3rd is a cube. So I'm going to use my same opposite, always positive, my ombre formula. So ombre means that the a would be x and this would be 1. So it would be x minus 1 because it's the same. This one's positive, always positive. So same, opposite, always positive. And then I'm going to square x, x squared. A times b would be 1 times x. And then b squared would be 1 times 1 is 1. Right? So if you're messing up on this first part here, you'd want to go back to yesterday's notes or the notes on sum and difference of squares. That was cool. So this is, sum and difference of cubes. So this part here, sum and difference of cubes. Cool. Let's do one more problem together. We'll do number 11 here. So number 11, the difference is that they're asking us to find the zeros. That means we want to know what x equals, right? So when we do what x equals, we're going to have 0 equals x to the 4th minus 29x squared plus 100. I'm going to remember that x squared can be turned into u. So I have really u squared minus 29u plus 100 still equals 0. I'll factor this, 100 and negative 29, negative 25 and negative 4. So I would have u minus 25, u minus 4. U is x squared minus 25, turning those u's back into x squareds. Still equal to 0. I see the difference of squares here, right? So I know that this is x plus 5, x minus 5. And I see the difference of squares again right here. This would be x plus 2, x minus 2. Still equals 0. Remember that we would get one solution from each of these. So I would say that x is equal to negative 5, flip the sign, positive 5, negative 2, positive 2. So all of those are my answers. Cool. That is it. You guys are going to work on number 12. Make sure that you did number 12 and you're totally done.